Hello, welcome back to my channel. On today's video we are going to look at two functions, that is the linear function and the parabola. So we are going to consider the parameters when drawing this graph. So as you can see, we have a an example, of a graph. So the line here, we're going to look at this line. In order to draw a graph, you need to consider certain parameters, as I've said. So we don't just draw. As you can see, we have a Cartesian plane, which means there are intercepts, right? There are intercepts somewhere, all right, that enable us to draw this graph. So what do you need to know in order to begin drawing a graph? So you need to have an equation. So you need to have an equation. All right, for example, we know that a linear function, right, it's that the equation is in this format, right? Y is equal to mx plus c, as well as ax plus by is equal to k. So you might see them in just these two formats, right? So you might see them in these two formats. So let us try and look at the first standard form. Let's just try and look at it, which says y is equal to mx plus ac. So the x and y are intercepts. So the y is for the y-intercepts on the Cartesian plane. So we know that this is labeled y, and the horizontal one is labeled x, right? So we can take these as number line because they are numbers on this Cartesian plane. So the positive x-axis, right, this is the positive side of the x-axis, and we have the negative side, right? So this side is considered negative and this side is considered positive, right? So above here we have the positive x-axis. So guys, remember, we are dealing with just basic math, right? So it's very basic, so we try as much as possible to explain the little details, right? Even from grade 8, grade 9, so we combine everything here. So as I've explained, right, I explained the x and y. So let us look at the next letter. So the next letter is m, right? So m is the gradient. This is the gradient. As for example, if I have something like this, right, so you can see that this line is a gradient, meaning it's a slope, right? So the slope is formed, all right, or consists of a number. Looking at the Cartesian plane, we can see that it's possible to find the slope. So it's highly possible to find the slope, right? So we are talking about something like this. So this is the slope at a certain angle. right? Meaning, yeah, it's a line at a certain angle, so it formed a slope. We want to know what is the slope of this line. What is the slope of this line? Okay, so yep. Now we are left with the letter C. Okay, so C is for the y cut, right? C, right, on the equation, the C is for the y cut, where y cuts the graph, the Cartesian plane. If I'm drawing something like this, you can see this point here, right? We consider this point as the y cut, so that is our C. Okay, let me just transform it. Let me try to transform that equation into something more clear. Okay, so that you can see what I'm talking about. Y is equal to, we can just say 2x plus a4. Okay, so as you can see, this equation right now, the x and the y, nothing has changed, but we have a coefficient of x here. Okay, so this is the gradient and that is our C. Okay, great. Now let us look at how to draw. Okay, let us look at how can we best draw the graph of this equation. How can we best draw? Okay, so what is it that we need to draw? Before I can draw, right, so we also need to look at the slope, right? That is the gradient. Okay, we showed an example like just like this. So as you can see, the slope is positive. The number 2 is positive. All right, so the number 2, right, is a positive number. So that helps a lot when drawing graphs. Okay, it helps a lot when drawing graphs to understand what does the M, all right, stands for, and how can you best interpret. Okay, how can the M, the gradient, helps us in knowing how will the graph be drawn. Okay, so I am pretty sure that the graph is going to be something like that. Okay, and I'm pretty sure that it's going to cut 8a4. Okay, it's going to cut where 4 is. Okay, where 4 is. Okay, it can be cutting down here at -4 or a4, but the M, right now I'm just talking about the M, will look at the C. So the M, okay, is increasing because it's positive, so it has to be something like this, right? It has to be something like it's either I'm just cutting it -4 and 4 because of the 4, right, that we have here as part of the equation. Right, so the M tells, because it's positive, then it tells us that this graph has to increase. The graph has to increase. Now let us look at the C. All right, so it tells us the graph is going to cut at 4. We are just not yet sure whether it's a positive 4 or a -4. All right, we are not just sure yet. All right, guys, so let's try and calculate. Let's try to calculate the x and y intercept. Okay, let's see what we have. So the equation is y is equal to 2x plus a4. So what you need to know is that when we are looking for the y-intercept, x becomes 0. Okay, when you want to draw these graphs. Okay, so x is 0 and then y is equal to 4. Okay, so write it as a point. You inserted 0 to get a 4. So input, output. Right, so we have 1 point. Let us look for the next point. Let us look for the next point. We're still gonna write down the same. Unfortunately, I'm not. Alright, so we're gonna write down the 2x plus the 4. So in this case, we're going to let y 0. Okay, when we are looking for x, let y be 0, and then we subtract the negative, negative 4 both sides. Okay, so we remain with something like this, and because we are looking for x, we are dividing. Okay, therefore x is negative 2. Right, so negative 2, 0. So this is our second point. So let us try to draw the graph. Okay, so we have 2 points. That is our points here. Okay, we have 2 points. We have 0 for negative 2 and 0. Okay, so 0 and 4 is, we can put it somewhere there. That point is 4, and negative 2. Okay, remember when I was mentioning where the negative axis and the positive y-axis, negative x-axis. Okay, so right now we can join. Okay, we can join the graph. Right, we can join the graph, something like that. Right, so this is the graph. So you see how helpful the gradient is. The gradient was showing us that the graph will be something like this. So if you mistakenly get confused, you draw something other than this, right, or a decreasing function, then you gotta look at the gradient. It's helpful, very, very helpful. Okay, so let us look at something. All right, let us just conclude something based on the gradient. How does the gradient help us to best draw graphs? Okay, so we're gonna consider some ways to interpret the gradient. So the first gradient was a positive gradient. We got something like this. So here the gradient is greater 0. Okay, so the gradient there is greater 0. And what about when the gradient is less than 0? We have something like this. It means that the gradient here is less than 0. Okay, let's consider another type of gradient when the line is horizontal, meaning parallel. Okay, so if it's parallel to the x-axis, if it's parallel to the x-axis, the gradient is equal to 0. Equal to 0, guys. What about if the slope or the gradient is vertical, meaning parallel to the weight? If it's parallel, yes, to the y-axis, what happens to the gradient? The gradient uh, is undefined. Okay, is undefined. So these are certain things that you need to take into consideration when drawing these graphs. Okay, I would like to add something to these graphs, the linear graph. Right, so what about the range and domain? The range and domain. The range and the domain of a straight line. Right, so when you're talking about the range, okay, range, you're talking about set of all y values, right? So range is set of all y values. Okay, so we use the y-axis to guide us. We just check where the graph is where the graph is concerned based on the y-axis, where the graph is defined. All right, where the graph is defined on the set of all y values. All right, let me write that clearly. Y. Okay, so we need to know whether the graph is defined on the y set of values. If I am to draw a graph like this, okay, what will be the range, or what is the range of that graph? Okay, so the range to this graph, there are many ways to write a range. Okay, there are many ways, but we're gonna look at this one. So if I am to, how do I teach learners how to draw or how to find the range? Okay, if you want to find the range, I advise you to draw, right, horizontal lines cutting the y-axis. Okay, cutting the y-axis. So if I'm to draw horizontal lines, okay, horizontal lines, you can see that these horizontal lines are cutting the graph, okay, everywhere. I'm not just following the graph, I'm just cutting on the y-axis. But when I'm cutting the y-axis, the graph as well is cut, right? So wherever the y-axis is, we can see that the graph is also there, right? Is defined. Where I'm cutting the y-axis, we find out that the graph is also defined. So we can say that the range, okay, we can say that graph ranges, okay, the graph ranges the graph ranges from negative infinity to positive infinity. Okay, so this is the range. Okay, it ranges from negative infinity to positive infinity. Okay, or you can just say y is the element of all real numbers. Okay, y is the element of all real numbers. What about the domain? Okay, domain is the set of all x values, the set of all x values. How do you find the domain? The domain we're gonna use the vertical cutting the y, the x-axis. We are going to cut the x-axis. All right, so I'm cutting, okay, as much as possible the y axis. Right, look at the red line. If you look at the red line, you see that on the positive as well as on the negative, I am cutting, okay, the graph as I'm cutting the x-axis. So this tells us that the same answer is for the domain. Okay, so the domain, all right, domain, okay, is from negative infinity to positive infinity. All right, or we can write it as x is the element of all real numbers. Okay, yep. So these are the things that you need to consider when drawing the graphs. All right, so I think that is clear. I hope that is clear. So guys, I would like us to also consider the parabola. Right, let's try to look at the parabola graph. So if I missed out on anything or you have a question, you are welcome to ask. Let's look at the parabola. The parabola has the quadratic function. Okay, quadratic function. If you have seen something like this before, then you have seen the quadratic function, that is the parabola plus c. Okay, so y is equal to ax squared plus bx plus c, or you can consider it in this form: y is equal to a x minus p squared plus q. Okay, so the p and the q tells us about the turning points. It tells us about the turning points. So we are going to focus much on just the interpretation, how to interpret. Let's look at these guys. Okay, let's look at an example that we can consider. Let's just assume something like this. Write down something like this: 2x squared. Okay, so looking at the format, this format, right, you can see that a is 2. Right, you can see that a is equal to 2. I think the color is not clear enough. Let's try and look at something brighter. So a is equal to 2. A is equal to 2. Okay, great. So great. Now if we are to draw this graph, okay, we're going to consider a table, just a table of x and y values, right? So we are going to consider a table of x and y. If that is x, this is y: -2, -1, 0, 1, okay, and 2. Okay, so we are going to do the input output. Right, so we already have the input, so this box at the top is for the inputs, below for y is the output. If we sub from this equation, okay, -2, we are going to get a 4. If we sub -1, we're going to get a2 sub 0 0 sub 1 2 sub 2 4. Okay, so from this we can draw the graph. From this we can draw the graph. Okay, so you pay attention to what I'm trying to explain. So if you are to draw, all right, so you can consider -2 goes together with 4. So if we are to point out that is -2, we can have 4 somewhere here, right? So they cross there or meet there, and we consider another point. So where they meet, all right, let me, right, so if this is 4, they meet somewhere there. Next point is -1 and 2, so they can be, if this is 2, they can be meeting somewhere there, 0 0. Okay, 0 0 and 1 2. X could be 1 here, and then y2 there, just this point, and 2 somewhere here, 4 somewhere there. So we can join these points, right? And we have something like that. Okay, we have something like that. So this is what we have. This is what we have. Okay, for this graph. So I just want us to learn certain things on this graph. What about, okay, what about if a was a -2? Okay, what about if a was a -2? If a is equal to -2, okay, so which means the equation will be -2x squared. What does this mean? Okay, what does this means? Let's just try and draw, okay, again that box, the same box, and then it's not what I'm looking for. Yeah, let's just try and draw this box, but this time around, oops, oh my god, Jesus. All right, I think this is much better. Let's just try and consider, okay, x, y, -2, -1 0 1 2. But in this time around, when we sub with a negative, so we're going to sub -2. -2 squared is a +4, then the answer is negative. Okay, then we're going to get a -2, then 0, -2, -2, -4. Okay, so we can plot this. Let's try and plot it. So -2 and -4. So if this is -2, -1 1 2, so we can put -4 somewhere here, so they meet right at this point. And -1 -2 negative, if we say this is -2 -1, and this is the point here. Okay, so 0 0 is this point. 1 and -2, they meet right here. 2 and -4, think that 2 is far. Okay, let me try and bring it closer. So let's just consider if it were just right here. So the point will be possibly here. So let's try and join the points. Okay, so we have to notice something. Okay, the graph here, okay, is facing upwards, right? So the graph is facing, look at this graph, is facing upwards, compared to this with a negative a is facing downwards. So there is something that we can conclude on. Okay, so when a is greater 0, okay, when a is greater 0, we have a minimum turning point. We have a minimum turning point. All right, so when a is greater 0, less than 0, sorry, we have a maximum turning point. All right, so these are the things that you need to consider when drawing this graph. These are the things that you need to take into account. All right, wonderful. All right, let us try and look at all right, I'll just write down the same equation and try to explain. If we have something like this, right? This is what we have: 2x squared. Okay, and we know that the one above is ax squared plus bx plus ac. So from this we can identify what is a, okay, what is b, and what is c. Okay, so a is 2, b 0, c 0. Okay, that is what we can learn from the graph, okay, above. So this is pretty much what you need to know, okay, about this. Now let us try and look at the range, okay, the range and the domain. Let us try to look at the range and the domain, okay. Let's make some room here and consider certain functions of okay, of a parabola. If we have something like that, that's not exactly, okay, something like that. All right, we'll try to look at this together. Okay, let's try to look at this together. All right, so yeah, let's try to look at this together. Right, I'm gonna bring this side. Think I'm gonna draw another one here. Okay, so I need to, let's say we have -2, -1, okay, -1. Okay, let me bring some more. Right, so this will help us to know how to interpret things like the domain, range of different types of graphs. Okay, so you gotta know how to interpret. So I think this is, it's not now, but at least we have an idea of how to interpret, okay, range domain. Okay, so the first graph, right? What is the domain and what is the range, right? So this graph starts, okay, looking at, okay, let's look at the range. It ranges, okay, it ranges from 0, okay, to positive infinity. Okay, it ranges from 0 to positive infinity. Okay, just this is, I'll just write something like that. It ranges ranges from 0 to positive infinity. Okay, what about the domain? The domain is everywhere, as we can see. X is the element of all real numbers, meaning from negative infinity to positive infinity. Okay, great. So let us move on and look at this graph here. Okay, so what is the range and what is the domain? So the range from this graph is from negative infinity to 0. Why am I writing the square bracket and the round bracket? Or the square bracket meaning it's not included since we don't know the number, but the round meaning including 0. Okay, 0 is included. All right, so that is the domain. That is now the range. Sorry, this is the range. The domain will be x is the element of all real numbers. X is everywhere for the graph. Okay, so let us look at another graph. Let's look at this graph. What is the range and what is the domain? So the range for this graph, it ranges from -1 to positive infinity. Okay, it ranges, as we can see, it ranges from, because below -1 going down it cannot be defined. Okay, so what about the domain? The domain is everywhere. Okay, so x is the element for real numbers. Because, like I said, if you were to cut, right, this graph vertically, you can see that it is everywhere. Okay, so it is everywhere. In case of the range, okay, it only ends here. Below here there is no graph. Okay, so that is why we say it ranges from -1 upwards. Okay, so if you were to follow that, then you'll be good to go. Let us look at another function. Okay, so what about this graph? What is the range? What is the domain? So I think I need to, let's just say this is 2. Let's just say 1. Okay, yeah, let's just say that point there is 1. So what is the range? What is the domain? The range is y is the element of all real numbers. It's everywhere. If I am to use the horizontal line to cut, right, I'll cut the graph everywhere. But as for the x-axis, I can continue this side, but I cannot, the graph, it's not defined from that point going forward, right? So then it means that the domain is, it ranges, okay, ranges from 1 to positive infinity. Okay, all right, great. Let us look at the remaining graphs, right? So just consider this point as -1 where the graph starts. So what will be the domain and range? The range, okay, the range is everywhere. Y is the element of all real numbers from negative infinity to positive infinity. That is what you can write. And the domain, the domain is from -1 to negative infinity, -1 going to negative infinity. Okay, great. All right, let's just come up here. Let's look at this graph. It ranges from the range of this graph from negative infinity to -2. Okay, negative infinity, -2, and the domain is everywhere. X is the element of real numbers. Okay, let us look at, okay, this graph here. The graph ranges, looking at the y, okay, from negative infinity, negative infinity to 0. Okay, and its domain is from 0 going to the positive infinity. Okay, so let's look at the last graph. This graph, this one here, what is the range and the domain? So it ranges from 0 to positive infinity, and the domain is from 0 to positive infinity. So the range domain of this last graph is the same. So right guys, thank you for your time and thank you for support. Please tune in by subscribing to this channel and hitting the notification bell. If you like this video, thumbs up the video, and see you on our next video. Yeah, see you on the next video.